Hutchison effect explained? People often ask, what exactly is the Hutchison effect? This brief essay is an attempt to answer that question to the satisfaction of the majority. First of all, the Hutchison effect is a collection of phenomena which were discovered accidentally by John Hutchison during attempts to study the longitudinal waves of Tesla back in 1979. In other words, the Hutchison effect is not simply a singular effect, it is many. The Hutchison effect occurs as a result of radio wave interferences in a zone of spatial volume encompassed by high voltage sources, usually a Van de Graaff generator and two or more Tesla coils. The effects produced include levitation of heavy objects, fusion of dissimilar materials such as metal and wood, exactly as portrayed in the movie The Philadelphia Experiment. I mean, this is something that we really cannot imagine. How can you join and fuse metal and wood? Now, the anomalous heating of metals without burning adjacent material, spontaneous fracturing of metals, which separates by sliding a sideways fashion, and both temporary and permanent changes in the crystalline structures and physical properties of metals. The levitation of heavy objects by the Hutchison effect is not the result of simple electrostatic or electromagnetic levitation. Claims that these forces alone can explain the phenomenon are patently ridiculous and easily disproved by merely trying to use such methods to duplicate what the Hutchison effect has achieved, which has been well documented both on film and videotape and has been witnessed by many times by numerous credentialed scientists and engineers. Challengers would note that their apparatus must be limited to the use of 75 watts of power from a 120 volt AC outlet. That is all that's used by Hutchison's apparatus to levitate a 60-pound cannonball. The fusion of dissimilar materials, which is exceedingly remarkable, indicates clearly that the Hutchison effect has a powerful influence on van der Waals forces. In a striking and baffling contradiction, dissimilar substances can simply come together, quote unquote, yet the individual substances do not dissociate. A block of wood can simply sink into a metal bar, yet neither the metal bar nor the block of wood come apart. Also, there is no evidence of displacement, such as would occur, for example, one were to sink a stone into a bowl of water. The anomalous heating of metal without any evidence of burning or scorching of the adjacent material, usually wood, is a clear indication that possibly the nature of heat may not be completely understood. This has far-reaching implications for thermodynamics, which hinges entirely on the presumption of such knowledge. It should be noted that the entirety of thermodynamics is represented by the infrared portion of the electromagnetic spectrum, which is insignificant to the context of 0 Hertz to infinite Hertz. The anomalous heating exhibited by the Hutchison effect shows plainly that we have much to learn, especially where thermodynamics and electromagnetism meet. The spontaneous fracturing of metal, as occurs with the Hutchison effect, is unique for two reasons. One, there's no evidence of an external force causing the fracturing, and two, the method by which the metal separates involves a sliding motion in a sideways direction horizontally. The metal simply comes apart. Some temporary changes in the crystalline structure and physical properties of metals are somewhat reminiscent of the spoon bending of Uri Geller, except that there is no one near the metal samples when the changes take place. One video shows a spoon flapping up and down like a limp rag in a stiff breeze. In the case of permanent changes, a metal bar will be hard at one end like steel and soft in the other end like powdered lead. Again, this is evidence of strong influence on van der Waals forces. The radio wave interferences involved in producing these effects are produced from as many as 4 and 5 different radio sources, all operating at low power. However, the zone in which the interferences take place is stressed by hundreds of kilovolts. It is surmised by some researchers that what Hutchison has done is tap into the zero-point energy. This energy gets its name from the fact that it is evidenced by oscillations at 0 degrees Kelvin, where supposedly all activity in atoms ceases. The energy is associated with the spontaneous emissions and annihilations of electrons and positrons coming from what is called the quantum vacuum. The density of the energy contained in the quantum vacuum is estimated to be by some at 10 to the 13th joules per cubic centimeter, which is reportedly sufficient to boil off the Earth's oceans in a matter of moments. Given access to such energies, it's small wonder that the Hutchison effect produces such bizarre phenomena. At the present time, the phenomena are difficult to reproduce with any regularity. The focus for the future, then, is first to increase the frequency of occurrence of the effects, and then to achieve some degree of precision in their control. The work is continuing at this time. Before long, we should see what progress can be made. This is by Mark Solis. It's on Bended Reality. Please leave your comments, and thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box. Now, John Hutchison, we don't know much about, but he's an American inventor. Alma mater, Lehigh University, Harvard University, known for awards, solid mechanics, William Prager Medal 1991, Timoshenko Medal 2002. Scientific career, fields of solid mechanics, Harvard University, doctor advisor. He was also a professor at Harvard, but it says here at the bottom of the article, Wikipedia, it's fair to say that Hutchison has been fortunate in many respects, not only in having the privilege to work in an environment which provides strong support to research with stellar colleagues and students, but also to have ripened as an engineering scientist at the time when the nation was heavily investing in engineering and applied science. He's been a thesis advisor to 36 PhD students listed at the end of his biography, a telling statistic which is not as unusual as it might sound for an active researcher these days, at least one who's been working for over 50 years, is that Hutchison has published almost 350 technical papers, and the number of different co-authors, distinct individuals, is nearly 200. Of these co-authors, about 65% were American, at least at the time the work was conducted, and 35% worked in other countries. Approximately 25% of his co-authors are Harvard students, postdoctors, or faculty. A further statistic which might interest young colleagues contended with today's academic pressure is that the first decade after publishing his first paper, Hutchison published an average of 2.3 papers per year. In the second decade, 3.8 papers per year. In the third decade, 5.6 papers per year. In the fourth decade, 9.5 papers per year. And in the fifth decade, 6.6 papers per year. Hutchison has received various honors, including the Timoshenko Medal of the American Society of Mechanical Engineers, awarded in 2002. In 2015, the Science Society Sigma Xi awarded Hutchison the first award, FERST, in recognition of his contributions to mentoring students. Many of his former PhD students were present at the festive ceremony at Georgia Tech University. Hutchison was elected to the American Academy of Arts and Sciences in 1976, the U.S. National Academy of Engineering 1983, the National Academy of Sciences 1990. In 2013, elected as foreign member to the Royal Society of London. He's been awarded honorary doctorate degrees by the Royal Institute of Technology, Stockholm, 1985, the Technical University of Denmark, 1992, Northwestern University, 2002, Lehigh University, 2004, and the University of Illinois, 2005. Hutchison was awarded the Ludwig Brandt Ring from the Deutsche Gesellschaft of Germany, German Society for Aeronautics and Astronautics, for outstanding contribution in the field of aerospace engineering in 2012. In 2013, he was elected a foreign member of the Royal Society. So he's a stellar scientist and inventor, as you can see. Please leave your comments. Thank you for your support.